let's do some guided practice. Note that for these problems, all I'm asking you to do is find and classify a local extrema. I am not asking you to find intervals of increase and decrease. So for here, second derivative test might be more helpful, right? Let's take a look, right? For number 1, f prime of x equals 2x minus 6. F double prime of x equals 2, which is always greater than 0. Okay, so actually, let's see. I should set this equal to 0. F prime equals, that implies x equals 3. So, by the second derivative test, f has local min f of 3, which equals 3 squared minus 6 times 3 plus 7. I think it's negative 2. Right? Because our second derivative was greater than 0, we have a local min. And that should make sense, right? If you know what a parabola looks like, it's facing up, so it should be that. Ugh, I once again apologize for that. There we go. Number 2, right? Here, let's try taking the first derivative, right? Second derivative test, probably easier for polynomials, but let's just see what we get here. This is going to be x squared minus 4x minus 32. Right, we want to let that equal 0. So, can I make that work? I think we can make that work. I think that factors pretty nicely. Yeah, sometimes you need to factor, so make sure your factoring is good. Nothing more than a quadratic, but good to remember. Okay, so these are our critical numbers. I'm going to go ahead and set up an interval chart. Now let's see. F prime, here's a nice little trick. You want to plug in some negative number, like maybe negative 10 or something like that. Just plug it into here and just look at whether each factor is positive or negative, right? Plugging in negative 10 into x minus 8 gives a negative. And then plugging it in here gives another negative. So actually we have a positive. Pop a little bit, right? Positive, right? Plug in 0 into f prime of x, and you get a negative. Right, again, negative 8 times positive 4. Plug in a big number like 10, you clearly get a positive times a positive. Okay, so here, by the first derivative test, f has local max f of negative 4, which, I don't want to do that now, and local min f of 8, which I also don't want to do out. So probably would have been a little quicker if we'd used the second derivative test, but we got intervals of increase and decrease for free. So if I had asked for those, then you would have gotten them. Okay. What about number 3? Here, you can take the second derivative if you want. Yeah, let's try both ways. I'm not sure if the first or second derivative test is better, so let's try them both. So we'll first try the first derivative test. F prime of x is going to equal 1 over 2 root x minus 4, right, times the derivative of x minus 4, which is just 1. Note that this does not equal 0, right? Because the numerator is 1, which does not equal 0. You can't divide a non-zero number by something and get 0. However, f prime does not exist at x equals 4. So 4 is still a critical number that we have to consider. All right, so if we go ahead and make our little chart here, we have that. Right, now, we have that now. One thing to keep in mind, I drew this interval chart, but actually, f of x and f prime do not exist before 4. So this isn't a real critical value, actually. But it is worth saying that when you plug in an x value greater than 4, you get a positive value. So here we could say f has no local max or min. Now, suppose we use the second derivative test, right? Well, again, we would have found that f prime of x equals 1 over 2 root x minus 4. Again, we note that that does not equal 0. But f prime of 4 does not exist. Now let's take the second derivative. We wind up getting, let's see, that's going to be negative 1/4 x minus 4 to the 3 halves, or the negative 3 halves. Put that on the bottom. I guess it looks like this. Right, and again, it's worth noting, or maybe it's not again, but like, it's worth noting that this is always less than 0. Right? So if the function is always concave down, right, and we know that that's true because the square root function looks something like this, right? Always concave down. See how it's just facing down? I guess we'll know about that later. Anyway, f has no local max or min. So kind of a tricky problem, but take your pick. However you do it, no maxes or mins.